Hello friends, I welcome you all on India's largest live e-learning educational platform, that is Gradeup. All the candidates who are joining me, just quickly confirm whether my audio and visual quality, everything is clear. And I seriously apologize for the delay, and I am really thankful to the video team from Gradeup. Today the session was really very difficult. It was not possible because there was some electricity fault at my residence. But anyhow, the best team which we are having at Gradeup, that is the video team, it helped me to anyhow figure out some solution to that problem. So I'm here. So all the candidates who are joining me, a very good evening to all of you. Welcome to the session. Just quickly confirm your presence by hitting the like button, like, share and subscribe so that maximum number of students can be benefited out of this session. Just quickly respond. Quickly respond. All of you. Everything is clear? Okay. Now friends, today we are going to have the second session in the series Vizag MT 2020, that is part 2 for electrical machines, most expected questions. I told you yesterday also that we will be discussing some general questions. Even though voice is low, please use some good quality earphone. I think voice is okay. Okay, so we'll be doing some questions that will be very generalistic questions, and that will give you a more kind of understanding of the topic, so that even a similar question or a related question is asked, you are in a situation to answer that question. I hope it is clear. So with these words, let us move on. Now this is my brief introduction. My name is Ashutosh Saxena. You must be knowing me or may not be knowing me. So this is my brief profile, as you can see on the screen. This is the first question we wanted to discuss. Everybody just go through the question quickly and tell me what is the answer you are getting for this question without wasting much time, because today we want to take more problems. So just see the question on your screen. It is related to induction motor. Just read the question carefully. Simple question, and I think you should be able to do this question. Everyone, come on. Only 5-6 students. Can't you share the session with your friends and colleagues? I want more and more candidates in the session so that everybody can be benefited. Anyways, I think candidates are slowly joining the session. Everyone who is joining the session, hit the like button, share and subscribe, and try to read the question carefully and try to answer. What is the answer? What is the answer? Triple R, great name. He's saying B. Now let us see what the question is asking. Question is saying a 4-pole synchronous generator driven at a speed of 1500 RPM feeds a 6-pole induction motor which is loaded to run at a slip of 5%, and he's asking what is the motor speed. Motor speed means he's asking the induction motor speed. What is the induction motor speed? Do you have any formula? Yes, NR is equal to NS 1 minus S. Now slip he has given in the problem. He is saying slip is 5%. So it is going to be 0.05. What is NS? Now you please understand, the situation is that this synchronous motor is actually feeding this induction motor. Yes or no? It means the synchronous speed will be decided by the frequency of the supply. That supply is nothing but the synchronous generator. Now he is saying synchronous generator is being driven at 1500 RPM. It means the synchronous speed is given as 120 F upon P. What is the P? P is the number of poles of the synchronous generator, that is 4. Synchronous speed is given as 1500 RPM. So from here you can calculate what is the frequency. Just calculate. You must be getting it. 50 hertz. Now this ns is actually the synchronous speed with respect to this induction motor. Are you getting this? This synchronous speed you are writing for the induction motor, nr is equal to ns 1 minus s. What is this ns? This is the speed of rotating magnetic field of the induction motor. So when you are writing ns for the induction motor, ns is going to be 120. What is f? F you have achieved 50 hertz divided by number of poles. The number of poles of the induction motor are 6. Just put it here. Just put it here. And I think you must be getting it as 1000 RPM. So what is going to be your answer? What is your answer? Everybody just tell me. Everybody just tell me. Yes, C, 950 RPM. If you put it here, it will be 950 RPM. Everybody is okay with this question? Just tell me yes or no. Everybody just tell me, are you okay with this question? Are you getting the whole idea? What is the frequency? How you have to take the frequency? The frequency you have to decide by the synchronous generator, and number of poles you have to take for the induction motor, so that you can write the speed of the induction motor. Everybody is getting that? Clear? Shall we move on? Next question. Read the question carefully. Try to give me the answer. Read the question carefully. I want all of you to solve all these questions like you are sitting in the examination hall. Everybody just quickly like, share and subscribe. Quickly like, share and subscribe. Now listen very carefully what the question is saying. Very easy question. If you take so much time to solve the questions, it will be very difficult for you to complete the question paper in the given time. As far as Vizag Steel paper is concerned, question paper is going to be lengthy. He is saying a properly shunted center 0 galvanometer. Now this information I am not interested. This information I am not interested because I am not handling the question related to the instrumentation. I am handling a question of electrical machines. Now he is saying connected in the rotor circuit of a 6-pole 50 hertz wound rotor induction motor. What is the meaning? The meaning is, if this is your induction motor, this is the stator of induction motor. Suppose this is the rotor of induction motor. Are you getting this? Now he is saying, when this galvanometer is connected to the rotor circuit of the induction motor, rotor circuit, what is rotor circuit? Now if you see the stator, this is the rotor circuit. The stator circuit is given a balanced 3-phase supply, and currents are induced in the rotor circuit. Currents induced in the rotor circuit, and these currents are going to have a frequency which we are calling as rotor frequency, and this is slip times the supply frequency. This is the relation, you must be aware with that. It means the current or the voltage at the stator circuit, they are having the frequency F, whereas at the rotor side, the rotor circuit, the frequency is slip frequency. I hope you must be knowing this. Now in the question he is saying that the galvanometer makes 90 complete oscillations in 1 minute. Now galvanometer is connected to the rotor circuit. It means whatever is the frequency of oscillation of the galvanometer is nothing but the frequency of the voltage and current at the rotor circuit. So can you tell me what is going to be the rotor circuit voltage and current frequency? 90 complete oscillations in 1 minute. Are you getting this? It means what is the frequency? What is the frequency? Just tell me, everybody. Some people are saying A, some people are saying D. Frequency is going to be 90 divided by 1 minute means 60 seconds. If you simplify this, it is going to be 1.5 hertz. Now this is the rotor frequency. Now you know that rotor frequency is nothing but slip frequency. So from here you can find the slip. Slip is going to be 1.5 divided by 50. Just find what is the value of slip you are getting. And from here you can calculate the rotor speed NR as 120. F is 50 hertz divided by P, that is the number of poles, that is given as 6, and this is 1 minus S. So put this value of S from here and tell me what is the value of the rotor speed you are getting. Everybody just tell me yes or no. Yes, what is the value of rotor speed you are getting? Tell me quickly. I think you must be getting 970 RPM. How many of you are getting 970 RPM? Just quickly tell me yes or no. D. How many of you are getting D as the option, 970? Clear? Any doubt you can ask me. Any doubts you can ask me. Go to the next question. Read the question carefully. Read the question carefully. Slowly we are increasing the level of the question so that you are competent enough to deal with any type of question which is coming. Just quickly tell me. See the question carefully. See the question carefully and try to find the answer. Now it is a little higher level, little difficult question. It is not that direct question. Everybody is getting 970 RPM. What about this question? What about this question? Read. Now I am saying you forget this question, that you have to solve this question. First you try to understand the logic. What is the logic? He is saying a 3-phase 50 Hz induction motor runs at the speed of 576 RPM, 576 RPM at full load. By what factor the rotor resistance to be increased for the motor to run at a speed of 528 RPM at full load torque? Are you getting this? Now I am getting a big question. Tapas Pradhan is saying, sir, one question, 3-phase induction motor is stator delta connected, is carrying full load and one of its fuses blows out. Then what happens to the motor? I will answer your question. Don't worry. First you do this question, Tapas Pradhan. Okay. You are bringing your own question. First do this question. First you do this question. Just read the question carefully and try to understand. It means he is asking you to vary the rotor resistance. Now rotor resistance you can only vary if you have a wound rotor induction motor. If you have a wound rotor induction motor or slip ring induction motor. Because squirrel cage induction motor, you don't have the access to the rotor circuit. Now he is saying the motor to run at speed, some speed at the full load torque. It means he is saying for both of these two conditions, the load torque is going to be same. This is the condition you have to use to solve this question. This is the condition you have to use to solve this question. Are you getting this? How you are writing the torque equation? How you are writing the torque equation of the induction motor? How you are writing the torque equation of the induction motor? It is going to be 3 E2 naught square upon 2 pi ns upon 60. This is going to be S R2 upon R2 square plus S x to 0 whole square. Yes or no? Now, as per the question, 3 is going to be a constant, E2 0 is going to be a constant, 2 pi ns 60, everything is going to be a constant. So I am writing this torque to be directly proportional to S R2 upon R2 square plus S x to 0 whole square. Now you see the speed. The speed is given as 576. If I am not wrong, the speed is given as 576 RPM. 576 RPM speed is given at full load. Yes or no? Now, one thing you must be knowing for the induction motor, that from no load to full load, the speed of the induction motor is normally going to be very close, just behind the synchronous speed. The slip is mostly going to be a very, very small value. Slip cannot be a large value. If slip is going to be a large value, there is going to be too much heating in the induction motor. We do not want that condition. So slip is going to be there. Without slip, the motor is not going to operate, but still the slip is going to be a very, very small value. It means if slip is a very small value, S is very small, so you can write R2 square is going to be very, very large in comparison to S x to 0 whole square. So my friend, I am writing torque is directly proportional to S R2 upon R2 square. R2 going to be cancelled, and you are getting torque as S upon R2. It means both the conditions you have to compare the torque, and you are saying the torque is going to be same. So I am writing the equation S1 upon R21 is equal to S2 upon R22. Use this equation. What is S1? Now S1 is going to be slip at 576 RPM speed, and S2 is going to be slip at 528 RPM. Yes or no? Now, if you know what is the synchronous speed, you can find slip S1 and S2. Now, what is the synchronous speed? Now, see, in this question, there is one more twist, and that twist is that in the question, he has not given you the number of poles. Number of poles are not mentioned, but full load speed is mentioned. And I just told you that for the induction motor, the slip is going to be a very smaller value from no load to full load. It means this full load speed is going to be very, very close to the synchronous speed. So what you will do, if you write ns is equal to 120f upon p, you keep on putting the different possible values of p, and you will get the synchronous speed. Now suppose you put, now f is 50, suppose you put ns is equal to 120 50 divided by 10. So you will be getting 600 RPM. It means you can guess, and that guess is going to be very accurate. Then there are going to be 10 number of poles in the induction motor, and the synchronous speed is going to be 600 RPM. So if you know the synchronous speed as 600 RPM, so you can calculate what is S1. S1 is going to be 600 minus 576 divided by 600. You calculate what is S1, calculate what is S2. 600 minus 528 divided by 600. Calculate these two slip values. R1, R2 dash, R21 and R22, this is something you have to find. And he is asking by what factor the rotor resistance to be increased. It means if you get the relation, pole is number 10. Okay. Just can you tell me what is the slip S1 and S2 you are getting? Can you calculate this? Everybody just tell me. Slip S1 and S2. Slip S1 you must be getting, as per my reference, 0.04. 0.04 per unit. And what is slip S2? Slip S2 is going to be 0.12 per unit. So what is going to be R22? R22 is going to be like this: S2 upon S1. S2 is 0.12 and this is 0.04. This is going to be 3. So what is that factor? What is that factor? Everybody? Yes, my God, electro board, perfect. So A is going to be the correct answer. Everybody is getting it? Everybody is getting this or not? Tell me yes or no. Yes or no in the comment section. Everybody is getting. Now I can see. Yes, 3, definitely. Let's see the next question. See the next question. Similar question. Similar means something related to finding the speed. So just try to solve this and see whether you are able to do it or not. Just try to solve this. Similar question. Can you do this question? Just little bit the language of the question is changed. Can you do this question, everybody? I'm waiting for your response and I feel no. I can say no energy. If you are going to write the examination on 13, you should be at the highest level of your energy. Okay, 45 seat. There are only 45 seats. 45 seats are there. Are you ready for those 45 seats? How many candidates are ready for those 45 seats? Just tell me and show me your Josh. Whether it is high, low, or extremely low. Great. Anik Mitra is directly telling me the answer. Somebody is saying BD. Bablu Kesal is saying 0.77. See, if you solve this question, you answer you must be getting is C. Same thing you have to do. Rotor of a 4-pole 50 Hz slip ring induction motor has a resistance of 0.2 ohms per phase and runs at this. Calculate the external resistance per phase which must be added to lower the speed to 1300 RPM, the torque being the same. Again. Torque directly proportional to slip upon rotor resistance. Torque same means torque. It is not torque, it is torque. S1 R21 S2 R22. Now my friend, you know 4 pole 50 hertz. Can you find the synchronous speed? Can you find the synchronous speed? Yes. Very difficult question. High school mathematics required. Then 1440 RPM, 1300 RPM, 2 speeds, 1 synchronous speed. Can you find 2 slips? Yes. Then he has given you the rotor resistance 0.2 ohms. Now he is asking what is this? R22 minus R21. Because he is asking the external resistance to be added to make the speed 1300 RPM. It means you have to calculate R22 minus R21. If you calculate, you will get C as the correct answer. Only one candidate is getting, and that is Anik Mitra. I think you must have attended my sessions. That is why without solving you are giving the answer. Anyways, don't take it personally. I am just trying to make some logic here. Read this question. Read this question carefully. Last question, comfortable or not? कितने लोगों को लास्ट क्वेश्चन जो अभी हमने किया है कंफर्टेबल है? अब उस तरीके का क्वेश्चन आएगा टॉर्क का तो निकाल लोगे. He will not give you separately that the slip of the induction motor is small. It is understood. Majority of the times with a good approximation you can say the slip of the induction motor is very, very small. So you can have that approximation. Everybody is getting that. Everybody is getting that. At least tell me yes, no, something. At least tell me yes, no, something. Yes, Anupama Kola saying yes. Now just try to figure out this question. Any guesses? Any answers for this question? Everybody is saying D. Great. Listen. What he is saying, listen. Firstly, listen. Very simple question, but understanding is important. He is saying the no load test. On a 3-phase induction motor was conducted at a different supply voltage, and a plot, it's not plotty, it's plot of the input power versus the voltage is drawn. This curve was extrapolated. Extrapolated means when it is restricted, still it is plotted. Extrapolated means when it is restricted, still Deepa Saxena is saying getting sleepy. Great. If you are getting sleepy, you can go to some other channel and listen some lullaby. You understand what is lullaby? Lullaby means lowri. You can listen some lowri, beta. Listen. And he is saying this curve was extrapolated to intersect the y-axis. This intersection points yields what? Now first thing you have to understand, when you are conducting the no load test, what is the meaning of this statement? Stator copper losses. They are present or absent during the no load test? They are present or absent? Tell me yes or no. I can remove all your sleep if you can answer my questions. I am saying when the no load test is performed in the motor, at that point of time during the no load test condition, stator copper losses are present or absent? You tell me. Stator copper losses are present or absent? Stator copper losses are present because supply is given to the stator circuit. Yes or no? Motor is on no load. It means load is not connected, but still the motor is rotating now. So some supply, some current is there in the stator circuit. Current is flowing, so stator copper losses will be there. Stator core losses. Stator core losses, present or absent, you tell me. Stator core losses, present or absent, that is what I am asking. You just say yes, no, present, absent, present, absent. Arey Baba, stator core losses are going to be present. If the stator core losses are not present, how the field is going to be coupled, how the motor is going to rotate? So stator core losses are also present. Again I am asking, rotor copper losses present or absent? Rotor copper losses present or absent? My friend, when you say the motor is on no load, it means the current drawn by the rotor circuit is going to be very, very small, because load is not there. The machine just needs to rotate, that much current it requires. So the current is going to be very, very small in the rotor circuit, and because it is no load condition, so rotor circuit copper losses are going to be ignored. Then comes the rotor core losses. Rotor core losses. Now listen very carefully, just raise both of your ears and listen very carefully. When the motor is on no load, it means the rotor is free to rotate whatever speed it wants, very close to the synchronous speed. So the slip is going to be a very small value. When the slip is going to be a very small value, the frequency at the rotor circuit, that is the slip frequency, S times F, S is a small value, so the slip frequency is also going to be a small value, and the core losses depend upon the frequency. Now the rotor core losses are going to be dependent upon the rotor frequency. Rotor frequency is a smaller value because slip is a very smaller value at the no load condition. It means what? Rotor core losses you can neglect. Now comes the rotational losses. Rotational, not rotational, let us call it as mechanical losses. Mechanical losses, present or absent, you tell me. Mechanical losses, present or absent? This is the final question I am asking you. Electrobot, I am coming to your doubt. Electrobot, I am coming to your doubt. Wait. Now mechanical losses are going to be present. What are mechanical losses? Mechanical losses means friction and windage losses. If the machine is rotating, whether it is no load or any load condition, machine rotating means friction and windage losses are present. It means mechanical losses are going to be present. Mechanical losses are going to be present. Now let me answer this question. Electrobot is asking, so why stator copper losses are present, no load condition? कर दी छोटी बात. This is your stator of the machine. This is the rotor. You are giving supply, 3-phase balanced supply. Are you getting this? Now the excitation of the rotor circuit is decided by this supply. It is not decided by the load. And when supply is connected, currents are there. So stator copper losses are going to be there, my babu. Are you getting this? Are you getting this? Yes or no? Are you getting this? Now you are comparing with the transformer. Now listen, what is the difference between the transformer? Induction motor is called a rotating transformer, but what is the difference? The transformer just need the induction from primary to secondary, whereas the induction motor, it is induction plus rotation. The no load current of the induction motor is as high as 25 to 30 or up to 40%. 40% of the full load current, rated current value. If you see the transformer, the no load current is just 5% or maximum by 10%. So induction motor is induction plus rotation. That is why the current is going to be comparatively high in comparison to transformer, and stator copper losses are going to be present, and stator copper losses are going to be present. Everybody is getting that? Everybody is getting that? Now listen carefully. So what I was saying I forgot. Now it means stator copper losses, stator core losses and mechanical losses are present. Now what I will do, these stator core losses and mechanical losses together I am going to call as rotational losses. Together I am going to call as rotational losses. Now he is saying, my friend, he is saying that the plot of the input power versus the voltage is drawn. The plot of the input power versus the voltage is drawn. So it is something like this. It is something like this. And this is suppose voltage, so it is going to be something like this. Approximate. Now he is saying this graph is extrapolate to meet at the y-axis, and he is asking what is this value? What is this value? My friend, you tell me. At this point, this is extrapolated. This is extrapolated. At this point, voltage is 0. My friend, voltage is 0. What is extrapolation? Doing something which is not allowed. You cannot extrapolate. You cannot go make this curve to touch the y-axis. Because when the supply voltage is 0, there is no meaning of the motor operation. But still you want to know the approximate value of the losses. Some losses. What are those losses? You are extrapolating this curve to cut at the y-axis. Now, when the voltage is 0, my friend, whatever power you are going to take, it is only going to give you the friction and windage losses. Friction and windage losses. Because every other loss is going to be not present. Are you getting this? Everybody just getting this? Tell me yes or no. See, Pradeep is asking डेली क्लास होती है. देखो क्लास डेली होती है, बट प्रॉब्लम ये है कि ये वाइजैग स्टील के लिए है, तो अभी तो डेली नहीं है. बट अगर तुम लोगों को चाहिए तो डेली भी हो जाएगी. मशीन के क्वेश्चंस अगर चाहिए तो डेली भी हो जाएंगे, बट यू हैव टू एंश्योर दैट यू कम टू द क्लास. आर यू गेटिंग दिस? Just stay connected, be regular. I will be coming with important questions for machine for GATE 2021 also. But right now we have to discuss for Vizag steel. Everybody is getting that? Now just see this question. See this question, everyone. Now see, we are running short of time, so I am just giving you some question as part of your homework, and some question I am going to give you as part of your homework. Try to solve those questions and send me the answers by writing in the comment box of this session. All the students who are watching me even offline also recorded, solve these questions and give your answer in the comment section. I will be giving you the question number because we are running short of time. बिल्कुल बिल्कुल प्रदीप करेंगे परेशान मत हो, करेंगे, वो भी करेंगे, क्वेश्चन सीरीज भी करेंगे, परेशान मत हो. दिस इज होमवर्क क्वेश्चन 1. Okay, I am giving you some questions because we are running short of time. So you just solve these questions in the comment section of this video. You please write the answers and I will give you what is the correct answer. Just take the snapshot. Homework question 1. Homework question 2. And I want all of you to comment these answers tonight itself, because we are having very less time. 13th December we are having the exam, so do not waste the time. Third homework question, Third homework question. Question number 3. Question number 4. Question number 4. Homework question. Question number 4. Question number 5. Question number 5 for homework. Question number 6. Question number 6. Easy questions. I hope you can do. Question number 7. Question number 7. Okay, do all these questions by today itself. Question number 8. Homework question 8. And who will give me all the answers by tonight itself? I will give you some prize. I will give you some prize if you give me all the answers by today itself. So friends, that is what I wanted to discuss for today, and definitely we will be coming up for more question series for GATE also, don't worry. Now it's time to conclude the session, but before I conclude, something very important information I want to tell you, that Gradeup is right now giving you now or never offer. The prices has been slashed for the 12, 18 and 24 month subscription. If you go for the Gradeup Super subscription, what you are going to get, I will tell you. I will tell you. See, Gradeup has become a one-stop solution to all your preparation worries. For example, for all the categories of students, we are having different courses. For example, if you want to read theory, we have Gear Up. If you want to practice questions, we have Rank Up. And if you want to do both theory and questions, then Vision 2022 is going to be the best and the most exhaustive course for you. Okay. For any clarification, you can contact the backend team. I think they are going to help you in the best possible way. These are the faculties in the electrical department who are going to mentor you throughout your preparation. All the faculties are going to be very experienced and expert in their fields, and they have produced a lot of candidates with a good AIR. Now these are the students who have qualified in 2020 examination, and 60 plus students have been in the top 100 slot. So you can also have your photograph here. Now what is Gradeup Super subscription? Just one subscription, and you will be getting access to all the structured live courses which are available at the Gradeup platform, and you will be able to access all the mock test, online mock test as the Gradeup Green Card Access, which are being designed by the toppers of the examination and relevant with the latest requirement of the examination. So friends, thank you so much for joining me in this session. Take care of yourself, and do not forget to join me in the coming sessions. Come to the Gradeup platform. There is a lot more you can say stuff which is available, and it is a good quality authentic matter which is available on the Gradeup app. So do come to the Gradeup app and join my sessions. Thank you so much. Take care of yourself. All the best wishes from my side for Vizag MT 2020 examination. And you must remember one thing, only 45 seats are there. Only 45 seats are there. So your written examination must be extremely good. Then only you can hope a seat, a selection in this examination. So from my side, all the best wishes. Take care of yourself. Prep smart, score better, go Gradeup. Thank you so much. Thank you so much. Take care. Thank you everyone. Thank you. Good night.